Now that you know how to factor everything, we're now going to take a look at some operations that are going to deal with factored polynomials. We're going to start with the products and quotients to start with. This is one of the easier operations to work with rational expressions on. So we're going to look at the following very basic case. X over A times Y over B. So if I'm multiplying two fractions, what do I do with those? Just multiply across the top, across the bottom. Very basic operation. If I could cancel beforehand, sometimes I would, depends kind of on the problem. Now the next one I'm going to look at is division. So these are the two different situations we're going to work with. X over A divided by Y over B. So with division is very similar to multiplication. The only difference is I have to change what I'm dividing into multiplying by the reciprocal. Once I do that, cross the top, cross the bottom, I'll just write them alphabetically. Doesn't matter the order. So with division, the only difference is that fraction that's being divided, I have to change that into multiplication and then by the reciprocal. So what our goal is to be able to get rational expressions. So a polynomial over a polynomial sometimes. And what my goal is going to be is to factor those things down and then go across the top, across the bottom. I am going to want to simplify along the way. Okay, remember that happy slashing I talk about all the time? The only way I can cancel anything out is if it's attached by multiplication. Right now, the only thing that's attached by multiplication is this quantity to this quantity, and this quantity to this quantity. So if top and bottom had the exact same thing in those parentheses, I could cancel them at this time. They don't. I cannot cancel anything at this point in time. The process you have to go through instead is factoring, because factors are going to be attached to multiplication. And once it's attached to multiplication, we can cancel things out in the top and the bottom when they're exactly the same. So this is when we have to start going back to factoring. This is why I've talked about how crucial it is that you can factor. So we're going to start with factoring my top left. So my product is 6. My sum is negative 5. So now I figured out, okay, what two numbers work? When you start looking at that, please be careful. 6s and 5s sometimes get messed up a little bit. My leading coefficient's 1, which means I can shortcut this. The two numbers that work would be negative 3 and negative 2. So therefore, it's x minus 3 and x minus 2. That's my top left piece. So what I want you to do is I want you to take a minute and factor the other three remaining polynomials. Get what those factors are. So hopefully you have all your factors. Take a minute, make sure that they're all exactly the same. So now for multiplication, everything goes straight across the top, straight across the bottom. So there's technically a multiplication sign here, and then there's a multiplication sign there and there. And in the bottom, there's one here. Technically, there's one here. It's right here. And then there's one here. So when I multiply, I just write everything straight across. X minus 3, x minus 2, x plus 6, and x plus 1. No need to expand. You'll make it uglier if you expand. And then x plus 6, x minus 1, x minus 3, and x plus 2. And now maybe some of you are going, hey, wait a minute, I know what I can do. Now, I wrote it this way because we cannot cancel unless things are attached by multiplication. And then they're above and below each other because they're being divided. So now I go through what's exactly the same thing in the top and the bottom. An x minus 3 and an x minus 3, exactly the same. They cancel out and become 1. And then I also have exactly x plus 6 and x plus 6. Those cancel out. And I also get 1. So my numerator is left with x minus 2, x plus 1. My denominator is left with x minus 1 and x plus 2. You can leave it as that. If you really want, you can expand it out and simplify. If you expand it, it has to be simplified. So the numerator would become x squared minus x minus 2. And then the denominator would be x squared plus x minus 2. So either of these two are my solutions to my initial multiplication problem. Most of you are probably going to leave it in factored form. There's no reason to have to go that extra step to multiply them through. Now, what I talked about is they had to be exactly the same in the top and the bottom to physically cancel out. There are a few unique cases where that's not the case. So there are 3 special cases that we're going to have to look at. Here's the first one, x plus 2 over 2 plus x. It's not exactly the same looking way. However, with addition, does it matter which order I do them in? So I can rewrite the top as 2 plus x, and the bottom is also 2 plus x. So what happens with those two? That cancels out and becomes 1. So exactly the same top and bottom. It's just written initially in a different order. Here's special case number 2. I'm subtracting here. Does order matter? Yes. But I can rearrange my order. What I can do is I can rearrange it so that my x's come first. It doesn't matter which way you go. 2's first or x's first. So I'm going to rewrite the denominator. Top same. Bottom, I'm going to reflip its order. So that's negative 2, or negative x plus 2. Those are not exactly the same, top and bottom. I cannot cancel them. However, what I can do is I can factor out something. In the bottom, I can factor out a negative 1. If I factor out a negative 1, the negative x becomes a positive x, and the positive 2 becomes a negative 2. Because when I expand this back through, I got to get back over there. And on the top, I have x minus 2. So when I go through, those cancel out, and I have 1 divided by negative 1, which therefore is negative 1. So they're not exactly the same in the top and bottom. The difference is their negativities. They switch which one has the negative. No big deal. I can factor that negative out and then cancel out. You're going to see case number 2 a lot, and you have to remember that your answer to that is negative 1. My last one, number 3. So if I try to factor a negative out of this, because they're not the same. So if I try to factor a negative out of this, I'll pull the negative out of the bottom. And that becomes negative x plus 2. Is that the same thing in the top and the bottom? No. This does not simplify at all. That is as simplified as it gets. If it's x plus a number and x minus that same number, those do not cancel out. Back to this example. We had an x minus 2 in the top, and I had an x plus 2 in the bottom. They do not cancel each other out. It's not possible. Just like the x plus 1 and the x minus 1. If the negativities flip-flop between the two, they do not cancel. If they just switched negativities, the one was negative and the other one was negative, that's when I can factor out that negative 1. However, in the bottom, just one of those signs changes negativity. That doesn't work. So let's look at one more example. I picked kind of a hard one for you. Take a minute, write this down. Okay, so the first thing we have to remember is what do we do with division? Well, with division, we change it to multiply by the reciprocal. So now that division problem that was kind of ugly initially isn't quite so ugly anymore because I just changed it to multiplying by the reciprocal. So now I have to look at all the different pieces to factor. I have to factor the top left, top right, bottom left, bottom right. So take a minute and factor as much of that as you can. Keep in mind that top left is a little bit on the uglier side to factor because it is a higher degree. So this will give you good practice on factoring higher degree polynomials. I'm going to do that one on a separate slide, and then I'm also going to do the bottom right on a separate slide too. Maybe you can figure out why. So take a minute, factor everything as much as possible, including that higher degree. So I'm going to start with the higher degree polynomial. Okay, I'll get the ugly one out of the way. So I have to go through and do the factor theorem. My leading coefficient's 1, which is nice. So I have to find the factors of b. So factors of b, positive negative 1, positive and negative 24, 2, 12, 3, 8, 4, 6. So those are all my factors of b. So now I have to figure out which one gives me a 0. I'm going to start with the smallest numbers just so I can do this without having to go to my calculator. Save as much time as possible. So I'm going to check p of 1. Does that equal 0? No. P of negative 1. So negative 1 plus 1 plus 14. Nope. I'm going to try 2. Now I might have to start plugging things in. Now I know when I plug in 2, I'm getting still a... it's not too bad of a number. So 2 cubed is 8. Plus 4, but then this is minus 28, minus 24. Too much negative. Okay, then I try negative 2. So negative 2, that becomes negative 8. This stays positive 4. This becomes positive 28 minus 24. Okay, that one looks a little bit better. Let's see. It does. The better you are in math in your head, the quicker these are going to go. Okay, just trying to figure out kind of some common sense pieces with them. So I found a 0. So therefore, I know my factor is x plus 2. So x plus 2 is my factor in this polynomial. So now I got to figure out what's left over. I'm going to do either synthetic or long division, your choice. I'm doing synthetic. So 1, 1, negative 14, negative 24. And then the number that made it 0 was negative 2. Remember, with the factor, it's what makes it 0. That's what goes outside. So drop down, multiply, add, multiply, add, multiply, add. Remainder 0, it has to be. So that makes this x squared minus x minus 12. Product is negative 12. Sum is negative 1. Two numbers at work, negative 4, positive 3. So therefore, shortcut, leading coefficient's 1. That's part of the reason we could do the factor theorem. So x minus 4x plus 3. Going back up here, my factors therefore are x plus 2, x minus 4, and x minus 3. So if I would have kept going to find more zeros, 4 would have given me a 0, and 3 would have given me a 0. So back to my problem. That was the top left. So the top left is x plus 2, x minus 4, minus 3, excuse me. And then I'm going to keep going across the top here. Product is negative 5, sum is negative 4. Figuring out the two numbers that give me my zeros, therefore is a negative 5, so x minus 5, and a positive 1, x plus 1. So there's my numerator. I can fairly quickly do the bottom left. Product's 5, sum is 6. That's x plus 5 and x plus 1. Yes, you should be this quick at this. You should be able to go through those trinomials really, really quickly by splitting the middle term, especially when that leading coefficient's 1. Now the last one is up bottom right. That one's ugly because it doesn't start with an x squared. A little bit different from what you're used to doing. I can factor it perfectly fine this way. However, if I rewrite it, it's the opposite of x squared plus 2x plus 8. When I factor, I like to have a leading coefficient of 1, so a positive 1. So I'm going to factor out a negative 1. And that gives me x squared minus 2x minus 8. You do not have to do this. It's just a tip of something that's going to help you kind of go through these a little quicker. So now my product is negative 8, my sum is 2. The two numbers at work are negative 4 and positive 2. And then I have this negative 1 as that multiplier. So just another way to try to help yourself out, just to make the problem go a little easier. If you didn't do that right away, it's not a big deal. You probably will end up having to do it later on, though, to get things to cancel. Not for sure, but most likely you would. So that's up bottom right. I have a multiplier of a negative 1. And then I have x minus 4, and I have x plus 2. So now I'll just go above and below. Cancel out what directly is related. X plus 2, x plus 2, x plus 1, x plus 1. There's an x minus 4 and an x minus 4. And that looks like everything. This negative 1, since it's a negative, I can pop it outside. On the top, I have x minus 3, x minus 5. And on the bottom, what's left is that x plus 5. I don't even need the parentheses there because it's the only thing that's down there. That negative sign is your choice as to whether you want to leave it down, up top, or in front. Just has to go somewhere. Okay? If I had a multiplier of a negative 1 on the bottom, instead of this, mathematically perfectly fine as well. Please don't try to cancel out these. If I factor a negative 1, for instance, out of x plus 5, that becomes negative x minus 5, which is not the same as x minus 5. So don't try to cancel too much stuff. That's why I went through those 3 special cases of when it's not exactly the same in the top and the bottom, but there are some nice things that take place. So what your goal is when you are adding and subtracting, or multiplying and dividing rational expressions, is just get stuff to cancel out. The only way you can get it to cancel, though, is if they are factors. So you're going to have to factor everything along the way and cancel what you can.